I want to show you another way of getting x alone when we solve for an equation. Remember this one? We couldn't do it in our head, so we had to get x alone. We treated that equal sign like a giant scale. Whatever we did on one side, we had to keep it even. We had to do on the other side of the equal sign. Now, it was strategic in this case to get rid of that plus 6.5. We subtracted a 6.5. But if I do it on the left, I have to do it on the right. Now, doing it on the left gets rid of it, and I have x by itself, and then I simply compute 8.3 minus 6.5, and I had the answer. And I have x, quote, by itself. Now, you could take that 1.8 and put it back into the original equation, and 1.8 plus 6.5 would in fact be 8.3, and that is the one and only solution that makes that actually true. What I want to show you now is that there are going to be other operations other than addition and subtraction that we'll need to use to get x by itself. Remember the various operations that we've used so far. Addition, well, its opposite. To undo addition, you'll use subtraction. And of course, to undo subtraction, you used addition. Well, what about the other two? What do you think you're going to undo multiplication with? You're right. It's going to be the opposite of multiplication, division. And division we're going to undo with multiplication. Let's look at an example.
Now what am I going to do?
We're going to solve this one. We're going to try to get x by itself. Now, who's keeping x from being by itself? The 3. Now, here's where you got to ask yourself, what is that 3 doing to the x? He's not adding now. When it's right next to the x, it's multiplying. And the opposite of multiplication is division. So that's the way I write division. So 3 divided by 3, that will get rid of that 3. Of course, if I do it on the left side, I have to do it on the right. Nicely on the left side, 3 divided by 3 is 1, or you can say it canceled out, and you'll get x. And on the right side, we get 11. So x does in fact equal 11. Let's put it back in and see 3 times 11 does equal 33, and you've got the answer to your question. Now be careful with this one. We know who we want to get rid of. The minus 4. A negative 4. Now what is that negative 4 doing to the z? Is he adding, subtracting, multiplying, or dividing? It's critical. Not only is it critical to decide what operation, but we'll have to decide the correct opposite operation. Well, actually, that negative 4 is multiplying the z. So there's not going to be any addition in this solution. We're going to divide by negative 4, because that's the opposite of multiplication. Divide by negative 4 on both sides. And let's see what we get. That'll go away, and we'll have 1z or z. And 20 divided by negative 4, be careful, is negative 5. So in this case, 1z or z with z by itself is negative 5. And if we put it back into the original equation, instead of z, negative 4 times negative 5 does equal positive 20. So it works. Let's do one more. This time we're going to solve for y. Who's keeping y from being by itself? The 5. He's multiplying, so I'll divide. Now don't be afraid of 0. He's a number. If you did it on the left, you have to do it on the right. Okay? So let's just do it. It's fair as fair can be. 5 divided by 5, well, that's going to cancel out, and you'll get y. And 0 divided by 5. Remember, what is 0 divided by 5? 0 is a number. You can do division. You get 0. And you can have 0 as an answer. The answer, the solution to this equation, is that y equals 0. You can even put it back in. Put a 0 in instead of y to the original equation. 5 times 0 does equal 0. So respect 0 as a number. He can be an answer. Get busy with that homework.